Problem 2 states, FM radio goes from 88 to 108 megahertz. AM goes from 535 to 1605 kilohertz. What wavelengths do these imply? Okay, so to do this, we're going to look at the relationship between the speed of a wave, v, and its frequency and its wavelength. So this is an equation that we remember from PHYS 153 in winter quarter. And specifically for electromagnetic waves, we know that the speed is that of the speed of light, c. So here we have c is equal to the wave's frequency times its wavelength. And we can rearrange this by dividing both sides by f to give us the equation as it relates specifically to the wavelength we care about. So wavelength is equal to the speed of light divided by the wave's frequency. So here we can start with FM. So FM goes from 88 megahertz all the way to 108 megahertz. And so we use the equation lambda is equal to the speed of light, which is 3 times 10 to the 8 meters per second, divided by the frequency. So we'll just start with that 88 megahertz. Of course, mega is the prefix for times 10 to the 6, so we're going to want to include that. So 3 times 10 to the 8 meters per second divided by 88 times 10 to the 6 hertz. And in doing this, we should arrive at a final answer of about 3.4 meters for the wavelength. And we'll call that lambda 1. Lambda 2 is going to be very similar, but instead of 88 megahertz, we're going to plug in 108. So it's going to be 3 times 10 to the 8 meters per second divided by our 108. I'm just going to tack on the times 10 to the 6 here for the mega instead of doing it in 2 steps. And ultimately, we find that this gives us a wavelength of about 2.8 meters. Okay, and so that is our wavelength range for FM radio. For AM radio, we of course have different values for the frequency, where our frequency ranges from 535 kilohertz all the way to 1605 kilohertz. Okay, so once again, we're going to say lambda 1 is equal to the speed of light, 3 times 10 to the 8 meters per second, divided by that 535 kilohertz. So in this case, we're going to do times 10 to the 3 hertz. And that comes out to equal 561 meters. Doing the same thing for the upper frequency, we're going to have 3 times 10 to the 8 meters per second again for the speed of light, divided by that 1605 times 10 to the 3 for the kilohertz. And this should come out to be 187 meters. And that does it for problem 2.